Uh, Welcome everybody. This is 47th Makercast. I'm Bradán Dopieralski, also known as the Shipu. And today we have four guests in the Makercast. So please welcome Bradán Lane, Moritz, Christian, Walther, and Guy Dupont. As usual, we will go around. First, we will do the introductions, then we will show off the things that we have been working on. And today I didn't prepare any quiz or anything like that, so we will just have a bit of a chat at the end, and that's it. So I'm going to do it in the order that you are there. So, Bradán, do you want to talk about yourself?
Sure, always happy to go first. So let me switch this over. Every year I do a challenge coin for various conferences and stuff, and they're nothing overly technical. The software is sort of a set of puzzles. There's a story puzzle and some interactive puzzles. They've got touch sensors on them, LEDs of various types. But I've always been kind of limited to what I could do. I was able to find a PCB manufacturer last year that was able to do things like black instead of white on any mask color. But I really didn't have much more to go with. And given I'm restricted on size and shape, it doesn't leave me a lot of creativity. And so when I went to do this year's challenge coin, I kind of started out with something very similar to what we've had before. But I really looked at this and said, of course, this is one of those little memory games. We all know what they are. But what it really needed was it needed color. And so I spent a couple, 3 months teaching myself old school classic silk screening, the emulsions and all that stuff, the old school way. Because what it turns out is solder mask is nothing but ink. And so as long as you can treat it like ink, you can do anything that you can do with ink. And the advantage to using solder mask ink for silk screening is it can tolerate all the reflow temperatures. So, your reflow oven is at 275 or 285 Celsius. Most inks will discolor at that temperature, but solder mask ink doesn't. So as long as I can work within the confines of the basic solder mask colors, the red, blue, green, yellow, black, and white. And because they're inks, I can also blend them if I want. I was able to do this with this, and remember, these are small. They're only, they're less than 2 inches across. But I was able to silk screen all the color on here just like before. And the process actually uses a lot of the same things that a lot of makers have. If you make more than just a small number of PCBs, you probably have invested in a manual solder paste stencil machine. Well, it turns out you can use that for doing silk screening too. And the process is exactly the same thing. There's a few differences. With silk screening, the frame is directly in contact with the PCB, but with silk screening, you need it to be elevated by a couple of millimeters. But the process is very much the same. You do your alignment, you come down, you do one color, and then this has to be cured in under UV light, and then you do another color, and then you'd cure it, and then you would do your last color or whatever other colors you have. But the process is very simple. Just uses, this one's been used quite a few times. It's got some stains in it, but it still works perfectly well. And then this is just vellum paper that I print on. And what I've learned is I need to do two copies of anything that I'm going to make a image of, because when I go to do the exposure, I need to double up that black so it's really, really, really black. And then I can do the UV exposure of the emulsion, and then I can wash it out and I can then set up 2 or 3 screens for one for each color that I'm going to do. And now that I've got it done and I've figured out what works and what doesn't, and I've made some mistakes. So one of the things I learned was it's really helpful to have a little bit of black as a sort of a framing around your items. So if I, let me find an example here. I'm working on a new one. This is an RP2040 based MIDI synth. And one of the things that I've learned is if I have this little tiny layer, this little black line, it's about, anywhere from 2 to 4 tenths of a millimeter thick. That gives me just enough margin of error that when I go to do my alignment of my silkscreen onto the PCB, any color that kind of overlaps that black doesn't show. And so it looks like a nice clean color. When I go to do this particular one, I'm going to lay down the PCB is going to come white with black on it. And I will lay down a gray background field. Then I will lay down a darker gray, which will be the drop shadow for the music. And then I will do, and you can, this is something that's fairly easy to do with silk screening. I can put down multiple colors on the screen and mix them a little bit and then do a pass of that. And I'll actually get this gradient in one shot. So that's kind of what I'm doing there. And then that's going to go on to this PCB, which, like I said, this is an RP2040. It takes MIDI in and has audio, single channel audio out. And the PCB that I'll order from the PCB manufacturer will have just the black circle on it and these 4 black touch panel or touch buttons. And also the center button there is a touch panel. But what's interesting here is I'm playing around with it. I don't know if it's going to work, but specification says this is a touch sensor wheel. So no moving parts, but theoretically I should be able to get and compute any point on the circle. So theoretically I can get a touch wheel, kind of like the first generation iPods, is my hope there. So silk screening of color PCBs is what I've been working on. And I've got 2 or 3 projects now in the wind that I want to play with.
Okay, thank you. So is this the end game for the PCB badges?
Well, you know, the quote unquote the holy grail of color is UV printers, but and a few outfits have played around with it, but you almost never see them come back. There's one sort of PC company or group in India that does a fair number of badges, and they've just switched over from their old silk screening methodology to using a UV printer. And they're having the same problems that others have, which is UV printer ink doesn't tolerate heat very well. So they're having to literally custom blend their inks, run them through a reflow oven to see how they change, and then come back and modify their colors to begin with so that they know what they're going to get out the other end. So you can't say, okay, I'm going to put blue down and get blue, or I'm going to put yellow down and I'm going to get yellow. They actually have to put down a slightly different color to get the end result. And so that's the biggest problem with UV printers. You don't have that problem if you're silk screening and you're using solder mask inks. So they can do much more detail.
Do that after soldering?
Some you can, and that is an option. Some you can't. It doesn't work out as well. So like if you want to put components down on the same face that has the color, then you've got a problem. But for a lot of designs, yes, you could create a holder that holds the component side down, and then UV printer across that. The other challenge with a UV printer is they're very expensive and they require a lot of maintenance. So if you can run it almost full time, that's great. But if you're only doing, 1 or 2 projects a year, you can't justify a UV printer. Whereas the cost here is, because I already had the solder paste stencil printer, which are US dollars 300 to 350. But because I already had that, my investment in this was about $50 in inks and another 60 or so in the traditional silk screening, 2 frames, a squeegee, some cleaning solutions and stuff like that. So this is a really low cost thing. I think it fits best with between, say, 10 boards and maybe 200 boards. You get much above 200 and much above 4 colors, and you spend a lot of time cleaning and prepping. But
Atomic 14 asks is if you could hack an inkjet printer for this.
Hack a what?
Inkjet
Oh,
printer.
the key requirement for being able to print onto PCBs is what they refer to as a flatbed printer. So a printer that the print mechanism moves, the material doesn't.
Right.
And almost all UV printers are designed as flatbed printers.
But if you could use like regular cheap consumer printer, like inkjet printer with standard cartridges, that could be.
Yeah,
And
I think
then you don't need the stencils as well.
Yeah, well, and that's the other thing with UV printers. You don't need any stenciling. You don't need to transfer artwork and emulsions and stuff like that. Again, the challenge is you need a printer that the medium doesn't move and the print mechanism does.
All right.
And then you also have to be able to adjust for height, because a printed circuit board is a lot thicker than paper.
Right. Another challenge for homebrew pick and place machines, I guess.
There you go. Yeah. But I've solved my UV, because this solder masking, as we all know, is UV cured, and that actually turned into being the bottleneck in my design or my workflow. Was I could print, or I could do the silk screening fairly quickly, but my UV curing solution was taking too long, and so I'd have to wait and wait and wait. I did about 100 boards in each session, and I could get through 2 colors in an afternoon, but I couldn't get through all 4 because I was constantly waiting for them to cure. I've subsequently solved my UV curing solution, so now it takes 30 to 45 seconds to cure, which means the boards are curing as fast as I'm printing them now.
Nice. Okay, let's go to the next person. So, let me operate this. Moritz, you're on next. Can you tell us about yourself and show us what you have?
Yeah, I'm Moritz. I'm a software developer as well, and my hobbies are also electronics and stuff. And today I brought a project which Aaron, or ATC 1441, got me into, and that's on these. Second. There we go. About these e-paper displays, and he gave me those at the Maker Fair in Hanover. And so I made a room sensor out of it. This is just the display, which I removed from the housing here. And that's what's really nice about those, is that the PCB inside them, which is this green one here, actually has a quick disconnect for the display, so it's really easy to get these out and repurpose them. They are held on with glue, and you can just cut through it with a knife. So these are really awesome to repurpose for your own projects, because you can get them quite cheap. But yeah, I made a PCB, which is this one. And the idea behind here was that we have some sensors up here, the SCD40, the BME 680, I think, and the SHT31. The SCD40 can also do CO2, and the BME one can also do gas resistance, but you need the BME software library so it can be correlated to any volatile components or anything. So I don't really use that feature of the sensor, but all of them do temperature and humidity, and the BME one also does pressure. So that's also a quite good reading for calculating the dew point and such. And also on the front, you can see it on the top left here maybe, I've added a ambient light sensor as well as an LED, and on the side a button for user feedback. And how this works is, on the back is an ESP32, a charging circuit with the D001 charging chip and USB-C connector. And then the circuit for controlling this e-paper displays is also done by ATC, which you can just copy and paste onto your PCB, and then you are able to just control these with the ESP directly. Yeah, and the design goal here was to use the least amount of energy as possible. But that didn't quite work out, so the PCB uses too much energy because I did some issues, so I'm also working on a new version. Because what I did do wrong was the reset line of the e-paper display needs a pull-up resistor, and that's because the ESP here can, or when it goes to sleep, the GPIO pins will float, and that can wake up the display, and then it will waste power. And the other thing I underestimated was the power draw of the sensors when they are in sleep. The manufacturers state that they only use a few microamps, but that in my case is not true. So I also need a transistor for turning off the sensors, because then when the ESP is sleeping, then they don't really use any power. And another thing that I didn't think about was the light sensor or ambient light sensor, which will use also energy, because pretty much it's a voltage divider, and the brighter it is, the more current it will draw. And therefore, yeah, the brighter it is in the room, the more energy will be drawn. So I need to turn off all the sensors, and for the display you can just go with the pull-up resistor. And now if I turn it on, I just have this battery here that I got from one of these e-cigarettes. These are also quite a good source for getting lithium-ion batteries for your projects, because the people just toss them on the street, and yeah, you can get these cells out of there. This one actually has 360 milliamp hours, but I've also seen people getting more than 500 milliamp hours out of there. And if I hook this up, you will see that the LED, which is pink in the top, will light up for a split second, and then the display will update. Let's wait for that. And there we go, took a reading. Another thing I did here is that the sensor data will be sent using ESP now. So I can just have another ESP lying around, which will pick up the messages and then put them into MQTT or whatever you like. And that's because to keep the power usage here as low as possible. I didn't want to use Wi-Fi or Bluetooth Low Energy or other means of communication, because I did some tests with some test scripts, and as you can see here, well, not that great. You can see that the Bluetooth Low Energy of the ESP will draw the most energy, which is 84 milliampere seconds for sending the payload. Then on the second place, we got Wi-Fi on the ESP. So just connect to the access point and then send a Wi-Fi packet to MQTT and then go back to sleep, which will use 54 milliampere seconds. And then here ESP Now was the winner for me, which only uses 17 milliamp hours per, 17 milliamp seconds, sorry. Which you can't see because it's on the right there. Let me see if I can, there you go. And as you can also see, the average current is also less for each of them, and the peak current is also different between these. Another thing that I optimized on the PCB here was actually in software, because as you can see here, I've got the sensors, and I measured that the SCD40 uses 830 milliamp seconds, because the, which is also interesting, this SCD40 sensor is a photoacoustic sensor. So it has a photodiode inside and some acoustics, and then with that it measures the CO2 concentration in the air. And that's why it uses a lot of energy for taking a reading, which is 830 milliampere seconds. So that's why it's not really suited for this low power application. But it is okay if you put it into the base station, which needs to be connected to power all the time, because it will need to relay the ESP Now messages to the MQTT broker or whatever. And another thing I found out that is the SHT31 uses the least amount of energy with only around 10 milliampere seconds. And the BME 680 using the Adafruit library uses 72 milliampere seconds, which is quite a lot if you think about it, because it's the BME 680 is just a fancy SHT31 with just 2 more sensors. So I took a deep dive into the code and found some room for optimizations, mainly how the communication with the sensor is handled. And just by switching that around, I could improve the power consumption to only be 16 milliampere seconds, which is, I think, 70% improvement. And so I also uploaded my code to GitHub, so everyone who wants to check it out, you can get it there. And that's just by changing. So what the Adafruit library does is, when you set up the sensor, you need to change the, so you set up the filter size and the oversampling for each sensor. And the Adafruit library does it in the way that you change the filter, then it communicates with the sensor. You change the oversampling for the temperature sensor, and it communicates with the sensor. You change the humidity sensor oversampling, and it communicates with the sensor again. And the same for all of the sensors. So, but the BME library that they're using internally actually uses the same data object for all of these settings. So what I just did is combine all of these settings into one function that changes the values inside the data structure, and then only communicates with the sensor once, and then we can already take our reading. And that's where we get the energy improvement, because we just don't need to spend so much time communicating with the sensor for changing a few settings that can be changed in one go. So that was very interesting to also see that you don't only have to, or that you don't only can improve the performance in hardware, but for low energy, but also can do a lot in software here. Just optimizing code so it runs a little bit faster. But what I also want to try in the second version is to run the ESP at a lower speed, because that I've heard also reduces the energy. The ESP will take longer for executing the code, but it will still use less energy while doing so than when it would run at a higher clock speed. But yeah, that's that project. And yeah, I hope you learned something from my findings. And yeah.
Are you publishing this somewhere apart from the library, of course? Like
no. What? I couldn't. It's very quiet here.
The question is if you are publishing this somewhere, like your findings, and you have a project page for this somewhere.
Yeah, I want to publish all the PCB and software for it, but I haven't done it because the project is not really done yet.
So, but I mean, it would be interesting to even read like updates on it.
Yeah,
and your findings as you make them.
There is already one video on YouTube on it, which you could watch. And there will be a second one where we'll go over some more things of optimization. For example, Makercast did also optimize the voltage divider that is used to measure the battery voltage. And he just turns the voltage divider off with the MOSFET when it's not in use. So it will also spare a little bit of energy there, which you could also do here, but it's in this case with a 1 mega ohm voltage divider, just a few microamps. So it's pretty much negligible, but it depends on your project. Because if this doesn't need to wake up that often, because you don't want it in this configuration, maybe you just want it to wake up once you press the button. Then you could also change the hardware a little bit more that it doesn't use any energy while it is sleeping, because you could put the ESP or turn it completely off and have it turn on when you press the button, because that's what essentially Makercast did in his pay-per-click project. So you could also go check that out, because that's also really interesting. He also did a few videos on that.
Nice. Have you thought about adding a circuit for battery protection?
Oh, there is a circuit for battery protection on here. It's the D001, and for charging I have the TP405.
Nice. Yeah, because I assume those batteries you get from those things that don't really have anything built out.
These are unprotected, so you really need a battery protection circuit for them.
Very nice.
Have you talked to Adafruit about the optimizations you've made? Maybe they'd be interested.
The thing was, I wanted to do a pull request on their repository, because one thing I also added to the library was that you can change the temperature offset, because the thing is that the BME 680 has some coefficients inside the chip which get burned during manufacturing when they do the initial calibration in the factory. And the issue was that, or the issue with these sensors mostly is that the reading of the temperature is always too high, or you have to calibrate it for your application pretty much, because what also Bosch says in their data sheet is that if you put the sensor inside a housing, you need to compensate for the temperature difference between outside the housing and inside, and due to the airflow and whatnot. So I found an issue on the Adafruit library where someone asked if they could add this temperature offset thing, which is just 2 lines of code, pretty much. That's why I added it to my library, because I also needed it. And the reply they got there was, no, we are not adding it. It's not part. It will not be be part of our library, and that's why I thought, yeah, then I will just publish my code on its own GitHub repository and just link to the Adafruit stuff, because I've also changed a lot of their code, so I don't know if they would be willing to accept the merge request, because it will probably change every second line of their code.
Yeah, if the API changes, then that's a problem, because they have all those guides already written, and they really don't want to change how you use the library. So yeah.
So that's mainly why. But if Adafruit is interested, they can look at the code. It's open source, and if they want to edit, they are. I'm happy if they want.
For sure, that's how open source works, right? It's out there. Okay, anybody else? If not, then we can go to Christian. Let me just figure out how to do this. Okay, Christian,
Okay.
your turn.
Hello, I'm Christian. I'm a software developer as well, and I also like bringing my software projects back into the real world using digital fabrication machines, but that's not what I'm going to talk about today. So this is a pure software project. So if you're a regular visitor to Makercast, you're probably familiar with these Pew Pew game consoles by the Shippo, like this, or like this, or I have more of them. So these are designed to teach game programming in Python in a very simple environment. For example, let me show you one. You can make such a snake game, for example. And so I have a couple of these devices, and then suddenly another device showed up that looks kind of similar. And so what do we do with that? I got the Playdate because I thought it was a neat piece of hardware, and I kind of liked the maker spirit behind its creation, where a software company, where a software company just one day thought, hey, let's do something different that we've never done before. Let's do hardware for a change. And then they saw it through to a mass market product, and I was quite impressed by that. So we've seen the snake on the Pew Pew device. Can we run Pew Pew games on the Playdate? Let's see what I've got. So apparently I can, but let's not get too excited yet, because this isn't as much as it looks like. So it's obviously a functional snake game, but it's still far away from my goal of running arbitrary Pew Pew games without modification on the Playdate. This is just a prototype. The game running here, it's not written in Python as the Pew Pew games are, but it's written in Lua, in the native language of the Playdate. And I can show you that. Can I show my screen, please? Thank you. So on the right here, we have the original Snake Python game as written by the Shippo in Python. And what I did is I translated this into Lua, as you can see on the left side. And then I implemented the Pew API, which is used by this game in Lua. It's a very simple API that wasn't a lot of code, so I could write that in Lua pretty quickly. And so you can see there are a couple of differences. The Lua one is a bit longer, and that's mainly because of these end statements that you need in Lua, or because you need to declare local variables, or also because there's certain functionality, for example, this in operator here that you have in Python that doesn't exist in Lua, so I had to write that as a function the name contains here. But other than that, it's pretty much the same code. And so how did I get to run this on the Playdate? For a change, I didn't have to reverse engineer anything for that, because the Playdate actually comes with a very nice SDK that you can download for free and use even if you don't have a device. So you can develop software for the Playdate even if you don't have one. And right, this is a short memory display, like you can buy the same display at Adafruit, and it has no backlight, so I need the lights on here. It's black and white. It's 400 by 240 pixels. It works quite well in direct or diffuse light. If you have light coming from a different direction, then you can't see much. The background is pretty specular. But in good lighting, it's really nice. So the SDK, I want to show you that. The main part of the SDK is a simulator that allows you to run the Playdate games on your own computer. And then you can write, you can write games in Lua or in C. For a Lua game, you just write some Lua code, like this main file I have here, and then you run it through a command line compiler that comes with the SDK, and that generates this application bundle, and you double click on that to open it in the simulator, and here it runs, and you can play Snake on the simulator as well. If you connect the Playdate by USB, it shows up as connected here in the simulator, and you can, for example, directly send the game to the device. It then mounts its flash memory as a USB storage device and copies things over. That takes a couple of seconds, so I won't do it right now. You can also do other interesting things, like, for example, send an image file to the device and have it immediately displayed on the display. That's quite useful for making mock-ups and seeing how they look on the real display. Memory LCD just means that it's a TFT display. Every pixel memorizes its state, but it doesn't work without power. In fact, you need to refresh it every second or so, otherwise the display burns in. So what else did I want to show you here? So the game you saw, as I said, it's not a real thing yet, it's a prototype, and the goal of the prototype was to get a feel of how Pew Pew games on the Playdate could look and feel. And I think it turned out nicely the way it worked, and let's start that again so you can see it again. So the way these pixels look, I based that on how the shipper once explained to me how he would imagine a physical custom-made LCD Pew Pew to look with a segmented black and white LCD display. So he imagined that the pixels would consist of 2 segments. So one segment with white stripes and does that work like that? Okay. One segment with white stripes and one segment with narrow stripes. And if you have only the narrow stripes on, you get a light gray pixel. If you have only the white stripes on, you get a dark gray pixel. And if you have both on, you get a black pixel. And so we have a black and white LCD here. So I thought, let's do a skeuomorphic Pew Pew LCD display. So to figure out how to do that, how these pixels should look exactly, I first set out to make some sketches in Photoshop and using this function that I showed you to try them out on a display. But I soon discovered that I wouldn't be able to sketch every possible combination of parameters by hand in Photoshop. So I really needed an interactive way of exploring the parameter space of these pixels. And so that's the first prototype I did. Maybe we can close the screen. I don't think we need that again. So that first prototype I made, I can show you that. That's this one. So there are just a couple of these pixels here. And using the buttons, I can now change the parameters, like making the thin lines wider or narrower, or make the thick lines wider or narrower. Or using the crank, I can shift the phase. And so using that, I found a nice set of parameters that works well. And that was 4 pixels wide and 8 pixels wide. And I think it was, yeah, the crank is nice. It's a gimmick, but for things like this, it's really useful. And you can also do things like I have a music box game in here that you can operate the music box using the crank. Or apparently the most obvious thing to do with the crank is making a fishing game. I haven't tried a fishing game, but a few people have apparently made them. So as you can see, when you change these parameters, there are some combinations that don't work well. For example, you can see here these artifacts between the pixels, and then I found one combination that I thought looked nice, and I went with that. And so that's where I am with this project. I have a snake game, but it's not a real thing yet. So the next step is bringing MicroPython onto the Playdate so that I can actually run Python code. And that's what I'm working on right now. MicroPython isn't really meant to be embedded in other applications, but it has a mode where it will compile into a bunch of C and H files that you can then just put into your other build system and integrate into your application. And that's what I'm working on. It's pretty minimal in the current state, but I'm currently working on enabling more features of MicroPython. For example, a file system. I need to read programs from the file system and so on. And I've opened a draft pull request on MicroPython for that, and that's what I'm currently working on. And maybe one other thing I want to show you about the Playdate that's interesting from a maker point of view, maybe you didn't know. I can take my power supply here and apply 5 volts to these screws, and it charges the Playdate.
That's neat. I guess they did that for debugging. For charging it at the factory, probably.
And I think they did for the dock they are planning. So that there's a dock that you can somehow magnetically snap it onto, and there are also people who have 3D printed their own docks and that then supply power to the.
And the screws are probably magnetic also, so you can connect to that. Okay.
Mm-hmm. Okay, that's all I have, unless you have questions about the Playdate.
That's awesome. That's really, really nice.
Oh,
if you get
I just thought,
MicroPython running that.
yeah.
So,
I didn't properly this demonstrate the charging because it was charging over the USB cable. So I need to show you that again. It actually charges over this connection. See?
right.
Okay.
So, do you think you can get the USB file system, like the file system exposed through USB on this, or do they use a separate chip for the USB?
No, it actually does that by itself. So if you can start it through the simulator, or there's a item in the settings menu. Why is it? I need to unlock it. Then the icon shows up here, and I can boot to data disk. And now that shows up as a USB drive here. Takes a bit. But I mean, if you mean in the sense that CircuitPython automatically reloads from the USB drive, I couldn't do that because it's not running game code at this point. It reboots into this disk mode.
Right.
So,
that's what I meant.
Okay, so here's that drive, and you can see all the games are in here, like my Pew Pew Maker.
I know it has 2 microcontrollers inside, and the games are probably running on the STM32, not on the ESP.
I don't know. Actually, I don't know exactly what's inside. I know it's an STM32, but I haven't disassembled it yet.
Yeah, right. I know there is STM32 and ESP32 for the Wi-Fi.
Okay.
But I guess they just use it as a dongle.
Of course, I could run MicroPython on either of these bare metal, but of course then it wouldn't be a Playdate anymore.
Yeah, that's a problem. I had the same problem with Blitz 32 from Pimoroni. Pimoroni? It's Pirate, so Pimoroni. Right. So they have basically their own loading system for the games, and I wouldn't want to break that to enable MicroPython. So I think this is awesome, especially since this is enabling people in the future to actually write games for Playdate in MicroPython, not just Pew Pew games. So I think this is really promising.
Yeah, you might do a binding to the normal Playdate API through MicroPython. True. But at the moment, I'm interested in Pew Pew because I like Pew Pews.
Thank you. Yeah. So thank you. And now, Guy, your turn. So please introduce yourself and show us what you have.
Absolutely. I'm Guy, and I have almost the exact same intro as everybody else. So I'll save a little bit of time. Software by day, hardware. My desk looks like this by night. And I have a few projects I've been kind of stockpiling a little bit. I had a child fairly recently, and fortunately have been able to find time to kind of at least remove ideas from my brain, but they get kind of piled up at various stages, but I feel like I finally have enough to kind of show, and I'm excited to be back. So I'm going to start with a project that I put out kind of before my child was born, and already made the rounds, but it kind of sets the stage for the follow-up. But so this is the dial toner, and I have the worst webcam, so I don't know if it'll actually focus, but yeah, no, thank you. Okay, well, good try. There we go. So this is a mechanical color picker. So each of these switches, they're basically like hex dip switches. So it's if you can't see around the edge, but it says 0, 1, 2 all the way through F. And so you have whoa, I'm backwards. Two nibbles, so a byte for red, byte for green, byte for blue, you dial in a color, and if you know how hex colors work, it's 24 bits, 3 bytes. And so you dial in a color, and then what happens on this side, man, my brain, this behind this button is an LED that glows in, you know, approximately the color that you have dialed in. So you kind of see where you are. And when you smash the button, this is plugged in over USB, and it sends the color as a string to your computer. Like it basically types the color in for you. So the idea was, you know, I wanted to make a tool that was like weirdly precise and very tactile, but ultimately it's not the most practical thing, right? Like picking colors is a very solved problem if you've ever opened a piece of design software in the past like 30 years. So, but I really like the idea of feeling it, dialing it in very precisely, and also like potentially teaching folks who don't understand what those hex codes are but use them all the time, which is the case for a lot of designers and even software developers. Kind of understanding the relationship between like each hex digit and the actual color that you see. So I did this, I put that out, I got a lot of feedback on it, and now it shows here this one is broken. This one is I don't know why the LED doesn't light up, but I'm not going to show it anyway. I put it out there. I got a lot of lovely feedback. I sold a bunch of them on Etsy, and it ended up in places where I didn't really expect. Like folks who put it in their kids' room so that kids can change the color of their lights. And I sold them to designers and stuff who just like to have it as a desk toy. Thank you, David. But I got a bunch of people who responded. They're like, "Oh, you should add this feature. You should add this feature. Oh, it'd be great if you could do this color space, blah, blah, blah." And my initial response was like, well, no, you're missing the point. Like the point is that it does one thing very, very precisely and well. But so I let it sit, and at some point in a newborn-induced, sleep-deprived mania, I decided, okay, what if I took everyone's suggestions and made like the polar opposite? What if I made like the actual Swiss Army knife version of this? So this is what I came up with, and this one hopefully actually works. This is the Dial Toner Ultra, and hopefully it'll power on. There we go. This one actually lights up. I don't know if you're gonna be able to see the screen. But so this one, as you can see, is a little different. It's got 4 potentiometers, and they're backlit. I just did some RGB, kind of cut them out behind the potentiometers, and it's got the LCD, one of the ST8779, whatever the SPY displays that folks are using nowadays. And what's cool about this one is you can use any color space for input and then any other color space for output. So it'll actually convert between, you can have it input hex, RGB. It's on CMYK. You can see I actually have the colors indicating what mode you're in for input. And I even did, after the whole Adobe Pantone thing, I added a cheeky little like Pantone mode, so you can select Pantone colors. But you won't be able to see the exact colors. But when I change the dial, the display shows both the text version of the CMYK, and it will change like the background of the screen will actually change to the exact color that you have dialed in. And when you hit the button, it'll send it to your computer in whatever like output mode you have configured. So yeah, I'll just change it to RGB just so you can see the difference. So I'm in my settings config right now. I'm going to change the input mode. Yeah, this isn't. I will do a video where you actually see me walk through this because it's not going to show up well on this webcam. But here, let's do RGB. And you can see now I'm in RGB mode, and the knobs indicate like what each of the dials do. And so if I crank up the red, you can roughly tell eventually, yeah, it's going to go full red. So yeah, it was super fun. I wrote all the code and did all the PCB design, everything, while my child and wife slept for the first like 3 months of her life. So this project is gonna, I think, have special meaning to me down the road, just because like it was like I was fully isolated, and I worked on it exclusively during that period where I was kind of like awake at ridiculous hours. And yeah, I'm hoping to do, like I said, an explainer video, and I'm hoping to get these up on Etsy too, because they're pretty easy to produce. Everything is like very hand solderable. It's just got a Zhao RP2040 on there and a couple of yeah, thank you, pots and multiplexer, and yeah, that's kind of the gist of it. So yeah, so and then I have one other thing to show. Also, same kind of like middle of the night, an idea kind of came to me that you know, who knows what I'm going to think of down the road, but right now I'm pretty excited about it. So the idea that came to me was like, what if you wanted to write an angry email or tweet something fierce? And I like the idea of like a guitarist has a pedal, and they can, right before they're about to rip a solo or something, they can stomp on their pedal, and their tone changes, and their tone is being processed in some new way, and they get this very tactile like foot thing, and then they do their thing. And I said, like, wouldn't it be funny to like stomp on a pedal and have it change your typing or something? Like what if instead of modulating an audio signal, what if you used pedals to change like data streams? So I'm designing a pedal which has not had a number of iterations, but currently kind of looks like this, that specifically changes human interface data. So you can see, rather than having a 1/4-inch audio jack for a guitar, it's got USB in and USB out. And so you literally plug your mouse or keyboard into here, and it'll just act as a pass-through. And well, it's not engaged, but when you stomp it, it'll apply an effect to your human interface data. So I tried to keep all the human interface, all the effects. Yeah, so stuff like that. Like you could write your own plugins. Like, yeah, you want to insert a clap emoji between words. You could write your own plugins for it, because I'm treating it like a multi-effects pedal. But all the ones I'm including in it are kind of rooted in an established audio effect. So I'll try to demo one. I have the raw PCB here. You can see I got the pot, toggle switch, LED, USB in, and again, I'm obsessed with these Zhaos. I put them in everything. But so like my favorite effect is reverb. You can put reverb on your mouse. So when you move your mouse and you stop moving, the cursor will kind of, it'll keep going a little bit. So let me see if I can actually demo that. Where'd my cable go? My cable's like too strong. It's gonna rip the PCB off the. Okay. I don't know if this is gonna work in real time. I have limited time to prep here, so it's not gonna. I just flashed this one. I might just leave you all wondering, because I don't know if this is gonna cooperate right now. But yeah, so yeah, I'm bailing out. But that's the idea, and I have a number of other effects. I have like for keyboard, like a delay, so it'll repeat keystrokes at an interval. And then what else? I have a like distortion for your mouse. So if you're dragging, it'll input noise and kind of make your cursor go crazy. And then the inverse of that is like a filter, like a low pass filter, where it actually smooth out your mouse movements, stuff like that. So yeah, it's mostly it's like many of my projects. It's kind of like an art project disguised as a product. But I always try to see if I could insert actual like bits of usefulness. So yeah, really excited to keep working on it. I actually commissioned a designer to to do a proper, I was not going to say test on it, a proper enclosure. I'm getting these. I found a person who makes the cases. He'll do all the drilling and UV printing for a pretty reasonable rate. I'll share that when I have the units in hand and I can actually vouch for the person. But so far so good. Yeah, it'll be all open source. Again, hoping to get them on an Etsy store sometime this summer. But yeah, and if anyone has ideas for effects, again, I like the idea of kind of rooting them in an established audio effect. But anyone has ideas like inserting the emoji, that's like a perfect thing. Yeah, so I actually am doing that. I don't have heart shapes, but I have a loop effect for mouse.
Is
that
RP 2040 Xiao on it?
Yep. All of my projects have ended up using the RP 2040.
Oh, you are using the software USB host on this.
Yeah. I'm using the BitBang, the PIO USB. So it's actually really cheap too. It's like it's not, the PCB is like, there's not a lot going on here. It's all through hole parts except for the Zhao. And this is like my first revision, so there's a lot I had to change, but it's still all pretty trivial stuff.
You could do a KVM on that, right?
I think so.
KVM.
Yeah.
Yeah, you need multiple outputs. Anyways. Guys, don't be shy. Questions, ideas for filters?
Yeah, hit me up. And if you don't want to do it here, I'm on Mastodon and still reluctantly hanging out on Twitter.
Yeah, you one thing, very simple thing. Just press caps lock randomly, so you get like hacker case thing.
It's in there already. Yep, that was the first one I did. Yeah, so I have the keyboard like cap modulation I'm thinking of it like tremolo, and so it'll capitalize for some amount of time and then lowercase, but then if you turn the knob all the way up, it'll just be a caps lock, on and off. If you turn the knob all the way down, there's the Easter egg, which I'm giving away to all you lovely people, is the random case. You got
it. Another thing you could have a knob for is the Zalgo effect. The
what effect?
Zalgo.
No, I don't think I know.
It's been popular like 5 years ago or something.
Okay.
You would just put all the most possible accents on letters and stack
them.
Ooh! So you get like a Cthulhu, like text with all those, and because
that's a great idea.
It was buggy at the time, so it would bleed into everything.
Yes. I've seen that. I've always wondered about. Okay, yeah, that's a great idea. Yeah, thank you.
So that's our, upside down letters done with Unicode.
You can do that with. That's where it gets interesting. Is I don't know. I have to dig more into because the whole world of like ASCII versus Unicode versus keyboard codes.
Right.
It's like you just gotta stare at it for a while.
Well, you would need two separate methods of outputting Unicode for Windows and for Linux.
Okay, good to know.
They have different shortcuts for that, but it's possible. It's doable, and I think you can actually detect what's on the other side, so you can choose the right method based on. But on Windows you hit right Alt and then numpad numbers.
Okay.
And type the Unicode code point, basically.
Okay, cool.
That gives you that Unicode character. On Linux, it's easier. You just do Control U and the number.
Okay, that's really good. That's really good to know.
I think Control Super or one of those mod keys. Yeah, well, there are actually keyboard communities where people know a lot of tricks for keyboards. That's useful.
Yeah, that's a good place to check too. I see a couple questions. I'll spit them out really quick. so I went about buying it. If I do sell them, which I am hoping to do, because I've already invested. Like my goal with all these projects is to just make make my money back, and then if people still want to buy them, I'll still make them. My default is Etsy, just because they make shipping very easy to anywhere in the world. Despite they take a pretty hefty fee, but my store, I think my store is called Esoteric Gadgets by Guy. So I'll share that in the chat too, but that's where it will be. And I'll announce it. Like I said, I'll announce it on like Mastodon and Twitter and stuff too when I'm ready. As for when, I'm shooting for like July. That hopefully we'll be able to do it. Can you pay me to do something crazy with the output of my enemies? Yeah, we'll talk for the right price. No, just kidding. There's one more. I think I saw.
So David asks if you can make a
pressure sensitive. Yeah, I was looking at like a wah pedal is the kind of classic other, if you're looking at guitar pedals, there's like the stomp box design, which is what I did, where you would just have a big old foot toggle switch. And then there's the wah pedal, which is like an expression pedal where you can go up and down. And you just buy those, and basically all it is a foot switch paired with a potentiometer. And so I could do that. It just seemed more expensive, so I didn't bother looking into it. I will say one thing mine does. I have it so you can switch between momentary foot switch and toggle, because like a lot of effects work like you might just want to press down while you're it'd be like the shift button rather than caps lock, so you can hold it down, type, and then let go. You can toggle between those. And I guess actually the last thing I'll mention very quickly is for I wanted to make the USB kind of look nice, not have these giant 18mm holes. So I 3D printed some nice caps, and obviously the final ones will be black or white or some cool color that matches the scheme. But they came out actually really well. This is in PETG, and then the other cool thing is I made them so they screw into my PCB. So I have little threaded inserts, and that kind of holds everything nicely in place, and also makes it so you can take it apart very, very, very easily. And so they kind of look like this on their own. That's all I got.
Thank you very much. So I guess that leaves me. I don't really have much to show. So I've been working on those robots. You've seen them before, and there were like 2 different workshops when we built 10 of them for people. One during the Hackaday Berlin meetup. So now we have some more robots around the world. So when the robot apocalypse comes, we will have our part in that. And but yeah, I was also playing with the deadline a little bit more. So I had in my drawer those tiny little servos. They are from Hobby King, I think, that are even smaller than the 9-gram servos that you are normally used to. You can can compare. Those are 2-gram servos. So I decided, okay, why not make like a baby version of this robot? So I even found the same kind of battery holder that that Fluffback uses, like this. Okay, but with the smaller battery footprint. Turns out there are like cylindrical batteries of all sizes you can you can buy, and they also come in LiPo versions. So that's super nice. This one is entirely done with PCBs, so the leg parts are also pieces of PCB. I didn't do the one big PCB where you break off parts, because nowadays the fabs will charge you extra for that, and it actually comes up to more than if you order separate PCBs. So those are all separate ones. But yeah, and it uses the Seed Studio Yao as well, because it's about the same shape as the ESP32S2, just smaller, so it fits. And yeah, it's oh, I had to move the button on the bottom because, and it's the same. Can I make it walk on something? The same idea. You have the walking robot that you can. This one doesn't have Wi-Fi, so I put an infrared sensor on it, so you can control it with a TV remote. A bit easier. The fluffback itself is controlled with Wi-Fi. So that's you know, that's simple. So I'm not going to be publishing this one because it's very fiddly, and you can no longer buy those servos. Those servos I bought like 10 years ago, and I couldn't find reasonable 2-gram servos out there anymore. I don't know, maybe people are not using them anymore. So I'm not. It's a one-time thing. But other servos I found, they are the same size as the 9-gram servos. They are much heavier than 9-gram because they are metal. Their servos. But the difference is mostly in the protocol that they speak. Usually, hobby servos just take PWM signal, and the width of the impulse gives you the position of the servo. Those servos speak serial. They speak half duplex serial, so just one wire is needed, because you either send something to them or they send something to you on the same wire. So it's an open drain thing. I used the RP2040 here because I hope to write a PIO driver for the half duplex serial. Right now I'm using a hack where I just use 2 resistors to connect TX and RX together and connect that to the drive. The thing is, those are smart servos. So as I said, they can reply to you on that serial, and they can tell you what position they have. They can tell you what current they are drawing right now, what load there is on them, and you can also tell them to move with a certain speed or to finish the move in a certain amount of time. So of course within capabilities of the motor. So this gives me options for actually doing more interesting things with this robot. So I can make it sensitive to touch, because if I can read the load from the servos, then I can do the same calculations that I'm already doing for inverse kinematics, but do the forward kinematics, and that will translate the loads on all the servos into a single vector that gives me direction in which the force is acting. So I could make you push the robot forward, and then it walks forward. Push it to the side, it turns. Of course, that's all. Right now, I just have the servos working, so it's already a success because the protocol turns out. On top of the serial, you have a packet-based protocol with CRC and so on. So it was a bit of an adventure to get that working. I have a library for that. It's published. So at least that part is working. Now I just need to get it, to work and react to things. Anyways, that's all I have. Everything's in progress. So thanks, and we can switch to general discussion if you want to. I don't have, as I said, I don't have a quiz today.
Thank you.
Another wants to suggest a topic for a chat.
I actually have to hop off really fast. I hear a child. So it was lovely to talk to you all. I will come back and rewatch whatever you all talk about. But
Okay.
yeah, I gotta hop off. Thank you for having me.
Later.
See you, guy.
Bye, everyone.
Bye bye. So I guess sorry, Bitluni, no quiz. Sorry, David. Yeah, I was thinking about doing, like one of those personality tests where you answer questions for yourself and then sum up some points, and this gives you, what kind of personality you have. But turns out, it's difficult to think of questions like that for makers, because everybody just ends up a geek at the end. That's, okay, then we can finish here. Give ourselves some time back. So thank you everyone for coming, and thank you for showing your projects. Next month we will probably have a Makercast live from the Exhain hackerspace in Berlin, or maybe that's in 2 months. I'm not sure. Anyways, every month there will be a Makercast now, so don't forget to come. See you. Bye bye.
Good night, everyone.
Good day.
Bye bye.